Warning that this video contains flashing lights that may not be suitable for all individuals. Viewer discretion is advised. Hello, my name is Dalton and I'm an engineer at CTR Electronics. Today we're going to be taking a look at a bit of an older product that has recently been introduced into the Phoenix 6 lineup of supported devices, the CANdle. CANdle goes beyond an LED controller, as its 5-volt, 5 amps of continuous current allows it to be used as a regulated supply for various coprocessors, such as a Raspberry Pi or NVIDIA Jetson Nano. In fact, a couple of our demos this past year used a Raspberry Pi in addition to the CANdle for its power. Out of the box, you'll get the CANdle and pre-attached wires. LED strips will need to be purchased separately at CTR-electronics.com. Let's talk about how you would mount this to the robot. Mounting can be done using the holes located on either end of the CANdle or the standoffs included in the box. On the back of the CANdle is pre-tinned leads for power and CAN on one end, and you have 5-volt, 12-volt unregulated, data out, and ground on the other end of the CANdle. So I went ahead and connected this CANdle to this LED strip here. This is one of the WS2812s we sell on our website, but the color coding for your wires may be different depending on where you purchase your LED strip. One of the rule of thumbs I use is usually on the LED strip itself. They denote what colors indicate do what. So in this case, red corresponds to the 5-volt going to the LED strip, green corresponds to data, and white corresponds to ground. So you'll need to match that to the CANdle. So if we go over here to this joint I made here on the CANdle, we have 5-volt on the LED strip going to 5-volt on the CANdle, data on the LED strip going to data on the CANdle, and then ground on the LED strip going to ground on the CANdle. The next step we'll do is connect the CANdle to our power supply and go ahead and get connected over CAN. Now that we have our LED strip wired into our CANdle, let's talk about the next steps, and that's programming the CANdle and playing around with animations and understanding what animation slots are, and that sort of configuration. So we're gonna go ahead and head over to Tuner, and you're going to wanna make sure your CANdle is up to date. You'll see Tuner here shows that a unknown or beta version is currently active, and that's because we're just using the 2026 pre-release here. So we're gonna go ahead and click into here, and we're gonna take a look at a couple of different configs here. So the first config that's very, very important is your strip type. If when you command your LED strip and you command it to red and it turns green or an unusual color, you probably have your strip type set incorrectly. You're going to want to go and check in Tuner to make sure your strip type is what the manufacturer says it to be. The WS2812s that we sell at CTR-electronics.com are GRB LED strips, so that's what we're going to be using here. The other thing we want to look at is the loss of signal behavior. By default, the CANdle, when you are sending a LED command, if you stop sending that command, it will actually retain the state of that LED. So if you set all of them to red and you stop sending, hey, set all of them to red, it will still keep them as all to red. Or let's say you have 6 animations playing and you stop sending those animation updates, it will still keep playing those 6 animations with the keep running behavior. The exception to this is if you power cycle the CANdle, you'll still need to resend those LED requests. They will not persist between power cycles. The last thing we want to check is the enable 5-volt rail config. That should be set to enabled if you're using a 5-volt LED strip, which we are here. Check your manufacturer's user guide for your LED strip to know if you're using a 5-volt or 12-volt LED strip. So now that we made sure our config's correct, let's get to controlling the CANdle. The first thing I like to do is just make sure I can control basic LEDs correctly. So we're going to go ahead and head to the animations tab in Tuner. We're going to head to solid colors. So we want to command this whole LED strip to red. So what we're going to do is we're going to add a new solid color. We're going to say red, and you'll notice a start index and end index parameters. So these match WPowerLib in that the LED index starts at 0. So the first LED on the CANdle itself is LED 0, and the last LED on the strip would be whatever your number of LEDs would be. I believe this is around a 60 LED strip, so we're going to go ahead and just command it all to 60. A little bit more than that, so let's do 70. So we're commanding about the whole LED strip to orange here, and we can actually go straight to red by manipulating RGB. So this is pure red here. So we verified that we can actually command solid colors correctly, and that red is red. If you command red and you're seeing green or blue or a different color, make sure you have your strip type set correctly. If the LED strip is not being commanded at all, make sure enable 5V is configured if you're using a 5V LED strip, and then make sure you have the direction or orientation of your LED strip. On your LED strip, you'll notice that there is an arrow indicating signal and where it should travel. The arrow should be pointing away from the input. So I have the candle here, which means our arrow on the LED strip is actually going this way. And you'll want to make sure it's configured. If you have it flipped around, your LED strip won't turn on. So we went around and we just set a solid color to the LED strip. What's the next thing we're going to want to do here? Let's delete this. Oh, I deleted the solid color. Why is my LED strip still red? This is that keep running behavior, where even though we've stopped sending the request saying turn red, it's going to keep it red. Now we can explicitly override this by just sending a LED request basically saying make it completely transparent, which effectively is turning the LEDs off. So if we just do 0 to 60 with completely transparent or 0 to 70 with completely transparent, we just turned them all off. And we're going to go ahead and delete that, and we basically reset our LED strip. So you can use that trick of just setting them all to transparent to clear your states if you're ever using the keep running functionality. Now let's talk about animations. Animations can be added to slots. You can have 8 slots at a time, slots 0 through 7. And a slot allows you to have multiple animations playing at the same time and allow you to divide them into in the LED strip. So let's start with an example of that. So we're going to take a look at slot 0, and we're going to command the fire animation. We're going to start this at LED 20. We're going to go till 30. And it can sometimes take a couple of seconds for the LED commands to make its way to the LED strip. So we're going to go ahead and command slot 1 while we wait for that. And we're going to go and do color flow animation. We're going to do 31 to 40. So here we have our fire animation and then our color flow animation. Let's make the color flow animation like a darker blue. And we can actually see that it turned a darker blue. And we can do this up to 8 times. We can divide this LED strip into 8 pieces. So let's go ahead and look at slot 2, and let's set this to Larson animation. And we're going to do 41 to 50. And let's make it nice and green. So we have slot 0, slot 1, slot 2. What happens if you have 2 slots commanding LEDs commanding the same LEDs? Let's find out. Let's add another Larson animation, and let's set this one also to 41 to 50. And we're going to make this one, what's obvious? So we did green there, so let's do blue. And you can actually see we actually have a little bit of overlapping in the colors as they are trying to play at the same time. Larson's not very clear, so let's make this color flow. We're going to do that same thing, 41 to 50. And we can actually see that there's this like stuttering effect in the LEDs. That's because it's rapidly swapping the LEDs between the color flow animation and the Larson animation. So you're going to want to make sure the LEDs you're commanding are unique between each slot. So in this case, I'm going to set this to 51, and we're going to set our end index to LED and then index 60. So now we have our nice segregated animation zones effectively. So another thing you'll notice here in Tuner is that you have this previewer at the bottom. This previewer, as you can see, mimics the actual LED state of the LED strip. So if your LED strip is embedded in the tuner or you're unsure what really should be happening, you can take a look at the previewer to really understand and just start playing around. The other thing we want to take a look at is we have a couple of different parameters here. So I'm going to take a look at color flow animation. Color flow, you can tweak the color here. You can tweak your start index in index, you can also tweak your direction. So if we take a look at the color flow here and I change it to backwards, we actually see instead of going from your perspective right to left, we're going from left to right. What happens if we increased our speed a little bit? So we can actually make this go quite a bit quicker. We're going really quick now, and we can actually go quite a bit slower, and now we're stepping. So you can use this to kind of adjust the speed of the animations. So you figured out what slots are, you figured out what animations are, you figured out that you can command solid colors for the LED strip. What is the next step? The next step is bringing this over into your robot program. To help with this functionality, we have included a generator utility that generates a utility class into your robot program that you can use to manipulate the state of your candle and your LED strip. This utility class will include functions for updating the LED strip, as well as all the animations and solid colors you actually configured here in Tuner. So it'll take the state you have in Tuner and it will translate it into code for your robot program. So I mentioned previously that the candle can be used as a regulated 5-volt power supply. That means the candle can actually be used to power Raspberry Pis, Orange Pis, and Jetson Nanos for usage as a coprocessor on your robot. So I want to take a look at the CAN range demo I have here. If you haven't already, take a look at the CAN range video for information on how that works. But in this demo, we actually have a carnivore that is connected to an Orange Pi that is running our API in Phoenix 6 to update the state of the candles here. But what is actually powering the Orange Pi? Because the Orange Pi doesn't take a 12-volt supply. Neither does any of the other devices. So what's actually providing 5 volts is this candle right here. So if we actually trace, and then I'll try tilting this a little bit here. If we actually trace the USB-C cable here, when we go along this pathway, we can actually see that it goes to the regulated 5 volts outputs of the candle. So this is outputting a regulated 5 volts up to 5 amps of continuous current to the Orange Pi to be able to do this demo here. So this opens up the candle to be used as a power supply for your coprocessors if you are doing vision on your robot, machine learning, and much, much more. Candle is an immensely flexible product both for LED control and general 5-volt output. We're excited to see how teams continue to integrate Candle into their robot designs, and don't be afraid to add us on social media with pictures or videos of how you integrate our products into your robot design. Don't forget to look at the Candle user guide and API documentation for more information on how to use the product. And that's everything you need to know about the Candle. Don't forget to visit ctr-electronics.com for your next project.